In this module, we're talking about the span of a set of vectors. And so I want to take a look at example 1, where we are given two vectors, v1 and v2, and we're asked, is u a linear combination of those vectors? And then part B is w a linear combination of those vectors. And because these vectors are in R3, they can be tough to visualize, tough to graph, but we have tools that can help. So I'm going to go to the internet and go to a site called Algebra, which allows me to do free 3D graphing. And I'm going to plot v1 and I'm going to plot v2. And so the vector 2, 3, 2 is v2. And you can see these vectors are plotted. The x-axis is in red, the y-axis is in green. So I guess it should actually be, well, you can rotate, but 2, 3, 2 is the red vector. And I'm also going to plot the plane that contains those two lines, and so this is the span of those vectors. And so now, when we go back to the problem, where it asks, can we express u as a linear combination of those vectors, you work through the algebra and you see that there is a solution. X equals 1/2 and y equals 3/2, and so 1/2 of the first vector plus 3/2 of the second vector equals vector u, 2, 3, 5. And again, we can see that on GeoGebra. So if I go back to the website, and if I plot the vector 2, 3, 5, you can rotate and you can see that that vector is contained in the span of the other two. Whereas if I continue with the example and instead use vector w, when I work out the reduced row echelon form of the augmented matrix, the last equation becomes 0 equals 1. That tells me there are no solutions. So w is not a linear combination. W is not in the span of v1 and v2. So here I have plotted v1, v2, and w. And you can see, if you look carefully, w is not in the span of v1 and v2. I guess it's close, but not quite in the span.